Hi, welcome to Module 3, which is on the artificial intelligence, machine learning, and deep learning. So in this particular module, we're going to take a deep dive into what's exactly meant by the artificial intelligence portion of artificial intelligence of things. So let's get to it. So this is actually Module 3 on control, where we will be talking about the foundations of artificial intelligence, AI, machine learning or ML, and deep learning. So these terms have actually been used a lot interchangeably in what we can see in the media. So I want to basically do a quick intro of this and also try to explain the difference between each of this. They are, of course, related. So first of all, this is actually part 3 of 4 modules related to this Grokking artificial intelligence of things. So this is titled Control, where we are basically looking at closing the loop within the information that we gather using sensors, the connections that we have to actually connect the data from the point of collection. And finally, once the data has been brought to the processing element, how do we actually use artificial intelligence techniques, machine learning and deep learning to do predictions using the data and then therefore detect what is the best or infer what's the best possible actions to actually control the situation so that we can actually get the most optimal result. So this is the outline. We'll be first talking about the introduction to AI, then an introduction to machine learning, and then an introduction to deep learning itself. And in the second part of this set of videos, this set of videos will be actually longer than the previous sets because we're going to take a deep dive into these interesting topics. The second set of videos will be actually talking about more practical exercise using a very common free cloud machine learning tool from Azure, from Microsoft, called the Azure Machine Learning Studio. We'll also be taking a look at some of the applications or use cases for AIoT in industrial IoT and smart cities, and also applications of AIoT in home IoT as well as personal IoT. So first of all, introduction to artificial intelligence or AI. Now it's important to actually take a look at this question because AI is a bit overhyped today because of the last few years. There has been a resurgence of interest in artificial intelligence, and many vendors actually want to put the word AI as part of their product. It could be the front of the name, the back of the name, or in the middle of the name. But exactly what is it meant when they say the word AI? And in some cases, you will find that AI does not even refer to artificial intelligence. It could be other associated terms like assistive intelligence or augmented intelligence or even autonomous intelligence. So whenever you see this acronym AI, do try to look a little bit deeper into it because there has been a lot of misunderstanding and also misuse of this particular term, AI, artificial intelligence. So what is AI? So the Encyclopedia Britannica has this interesting definition for AI, and in it, it says that artificial intelligence is the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. So there's a few things that we need to take note in this definition. First of all, when we say intelligent beings, really we are referring to human beings. So not other intelligent beings like dolphins, or some people may even say dogs. So we are really referring to tasks that are being performed by humans, that when the humans are able to perform these tasks, we deem them as intelligent. So this is the first point. It's actually trying to perform tasks associated with intelligent humans. Second point is that actually, and this is actually the source of a common misconception, and that is actually we are not actually trying to create a computer program or robot that can think like a human. Notice that the definition does not say AI is the ability to create an artificial brain or an artificial ability to actually think like a human. It is merely creating programs or computer controlled robots that are able to perform things that we associate, we are able to mimic. Okay, we're going to create programs that can mimic or imitate the tasks that are performed by intelligent human beings, not to be able to replicate the way humans think. The task of being able to replicate human thought is actually the original aim for artificial intelligence when it was first defined in the 1950s. But that actually proved to be a very difficult goal to actually achieve because we don't really have a full understanding of how humans actually think. Right, the theory for thinking for humans, how we are able to understand language, how we are able to plan our movement through a 3D space, how we're able to look at a picture and immediately recognize what it is, how we're able to hear a certain sound or certain word and also recognize what it actually means. All these abilities we can do in our brains, but we have no idea how that processing actually occurs. So when it comes to actually creating an artificial brain, we are really very far away from it. So the original goal of artificial intelligence over the years has shifted from that original goal of trying to create an artificial human brain, or the ability to create something that can think like a human, to merely a simpler, much more reachable goal of performing things or imitating tasks that we can associate with an intelligent human being. Some experts have termed this weak AI, W-E-A-K, weak AI, whereas the original form is a strong AI, that means it's actually able to think like a human. So this is actually the state of the art that we are in today. So important takeaway from this course is really that AI and human intelligence are very different things. So it's not very helpful to compare the two because AI does not equal human intelligence. And when we try to compare the two, we are trying to compare apples with oranges. So we cannot think in terms of AI is greater than human intelligence, nor can we think of AI is lesser than human intelligence, because they're just two different forms of intelligence that can perform certain things. However, we can compare the task. Is the AI being able to perform that same task at a higher level of performance than the human? That's meaningful because we can objectively measure the result. But being able to think like humans, no, that is actually something that is very difficult to quantify as well. So the first point is AI and human intelligence are really quite different. So in the AI of things, or in artificial intelligence of things, really the things of physical objects and robots and other devices that we have in the network, they do not think like humans. Okay, they are merely able to perform some things that humans are associated with humans. So let's try to distinguish between the artificial intelligence of things and also this classic computer programming or algorithms. So in a classic computer programming scenario, we may have a task like this where we have a list of numbers and we are trying to actually sort these numbers from the lowest number to the highest number. So this is the output that we want on the right. Let me just get my laser pointer. So this is the input, and we actually want the output to appear in this fashion. And we accomplish this by actually running some sort of software that runs what we call a classic algorithm through the programmable computer. Now, this is not considered artificial intelligence because there's one important thing about this algorithm. The intelligence in this algorithm is actually being put in by the programmer. Because what the programmer needs to be able to do is to actually break down this problem into a step-by-step approach. He has to decompose the problem into very explicit steps in order to solve this. How explicit it is, let me just say that for those who are not used to computer programming, first of all, you need to specify where do you start. So let's say you have to start from this number, and you also have to specify where do you have to stop, right? And you also need to specify how do you perform the step-by-step execution of sorting the numbers. So the very first step is basically to first take the first number and compare it with the next number. And if they are out of order, what do you do? So a very simple algorithm is called the bubble sort algorithm. So where there are two numbers, you take the first number and the second number, and if they're out of order, that means the first number is actually larger, you swap the position. So these first two should be swapped. Then once the positions have been swapped, you take the next two numbers, and again, you do the same. Okay, it's this number and the next number in position or out of position. And again, the numbers are out of position, so you swap it again. And you proceed in this manner, swapping if the numbers are out of position. Now, if they are in position, you just leave them as it, like these two numbers, they're in position, right? The first, these two numbers, they're in position. So this first number is actually smaller than the next number. So don't do anything. Just skip this pair and just go to the next number and compare the other two pairs. Again, they are in position, so you don't do anything. So you can see that actually the program has to be very explicit. The programmer has to say what the program needs to do at every step of the way until you reach the end. So once you reach the end, you just continue again from the front and you keep on doing this. Now you need to also specify what you call a terminating condition, because otherwise you're just going to do this comparison over and over again to infinity. So the ending condition is that if you can actually do one pass from the beginning number to the last number, and there are no numbers that it needs to be actually exchanged or swapped, it means that all the numbers are already in the sorted order and you can stop. So that is actually the terminating condition. So this is actually what we do in a classical computer program, right? We actually need to break down the problem or decompose the problem into a step-by-step approach and run it through a computer to actually get the result we want. So this is not considered artificial intelligence, even though humans can still do this, but really the intelligence is not in the computer itself. The intelligence is really what in the human programmer who actually broke down the problem into a step-by-step approach. Even something that is more complicated, like this case, where we have an input from a computer and we want to basically do a search, internet search, to find all occurrences of pictures of the horse on the internet. It seems to be magic for the public. We just type the word horse into our search engine. Let's say our first favorite is Google, and the result magically comes out. But from the programming point of view, this is not artificial intelligence because it can be broken down into a very much a step-by-step approach. First, you input the word on your browser. Once you have captured it, you may change it to a common case like all lowercase. Then once you still have to break it down to an algorithm, right? So the algorithm first is get the input. Second part of the algorithm is basically do a search by sending the result into a huge information base or database that actually Google's captures. So Google actually runs a very huge database or information base where it's basically searching the internet for relevant information, and it stores the information together with the location of the information and the associated word with that information in an what we call an index to make it easy for you to retrieve information. So once we send the search word into the index, the program that's on Google's end will basically just search through all what it has already pre-searched. Of course, it's quite interesting that it's able to do this very quickly. Retrieves all the information and send it back to your computer, and then your computer will just take all the links that's being produced to basically retrieve on each of the images one by one, very quickly display them on your browser. So it seems to work like magic. You type in the word horse, you get all these pictures of horses coming from the internet, and you have pages and pages of it. But it is actually not magic, but something that is broken down. Is similar to the previous sorting number example, just a standard computer program, right? What you call a classic algorithm, which can be broken down into a step-by-step approach. So you don't consider this AI. How about something that's slightly more complicated? You as a human, take a look at the picture of that animal at the left there, and most of you can also probably immediately identify this animal within less than a second. And you can say that this is a horse. Now, we are not sure how we do this. We are definitely not looking at each of the individual pixels in this picture. So a computer image like this on your computer now, what you see as a horse, as the image of a horse is really many, many colored dots, right? What we call a pixel in each of this. So there are actually literally thousands or if not millions of dots that make up this picture. And when we try to interpret that picture of a horse, we definitely do not look at each of the individual pixels. Is this pixel, the tail, or is this pixel the eye, or etc., or is this pixel the body? We don't actually look at the pixels individually. We just recognize the whole image as it is through some sort of algorithm that's running in our mind. Definitely, it's not step by step. We don't look at pixels one by one, as I mentioned just now. right? We do some sort of overall processing of this image, and we can immediately recognize it's not only is a horse, but it's probably a happy horse eating grass on a grassy plain. Now, if we are able to mimic somewhat similar, get a similar result, right? We don't want to think like a human. We want to input this picture, run some image recognition or classification algorithm through the computer, and we can get the similar result that the output is horse. Then basically we have been able to mimic or imitate that intelligent human behavior, the one that we are able to do in our heads, right? Take a look at the picture and instantly recognize the horse. We can do that. If we can do the same thing with the computer, then by definition, this is a form of artificial intelligence. It's definitely not done by breaking it down into examining each individual pixels one by one. A computer program that does this also does not do it by looking at each individual pixels one by one. It's not a step-by-step approach. Okay, so if you are able to break the problem down in a way that can be executed on a computer and imitate the human, so this is actually a form of artificial intelligence. Now, the algorithm that's being used is probably very different from how a human being does it, right? And so it's not useful to measure the performance of this algorithm against whether it thinks like a human. But however, we can actually examine the output. Is this algorithm able to recognize the horse when the picture is less than perfect? Maybe there's some blurring of the picture, or the picture is very small. Is the algorithm that we run through the computer able to achieve that recognition with higher accuracy than a human? Okay, and the answer for this is actually, for today, the best algorithms that we have available, it can actually do this task better than a human. If the picture is blurry or small, best computer programs can actually recognize the picture of the horse with higher accuracy than humans. So this is actually superhuman performance. It is possible that an AI can have superhuman performance, right? Very good algorithms today, actually state of the art, can beat humans at certain tasks. However, the way it does it is really different from how a human does it. Just to illustrate why this is the case, if I change the picture of the horse to a blue horse, right? I change the color of the horse to blue, and I put the horse on the moon, you will still instantly recognize that this is the blue horse on the moon. We are not quite sure how you do that, but we have this notion of common sense. We have some concepts in our head that we can instantly recall, and we can overlay over the picture of the horse. However, if I were to change the context like that for this computer program, even the best program that would have been able to beat the human at recognizing the brown horse on the grassy plain, if I put the horse on the moon and change it to a blue color, no program will beat the human at the task. In fact, it will fail miserably. So this is just a case in point to prove to you that really AI is not the same as human intelligence. Even for the same task where you can actually beat the human at it, if we were to change the task slightly into a different context, actually most AI programs today, they won't work at all. So this is one thing that you should take away. Okay, it doesn't, even though the AI can imitate human behavior or human intelligence, it doesn't think the same way, right? The way it processes the information is very different. So you shouldn't compare the two. And the other second takeaway is that actually it's still possible to achieve a better performance than the human for certain tasks if it's within a narrow domain. So if it's within a narrow domain, the computer processing will always be the human, because humans get tired, they may not pay as much attention, and they will have difficulty looking at the fine points in the picture, whereas the computer program will just relentlessly crunch numbers and look at every single detail in the picture that may escape the human's notice. So here's the activity, and you can pause here to just think of what are some of the actions that humans are able to do that you can associate as an intelligent behavior. You can pause the video here for a few minutes, and I will just give you a few minutes to think about it before I continue. What are some of the things that humans can do that we, by them being able to do this, we consider them to be intelligent? So the first of it is probably one that many students will come and tell me is that the image recognition will be able to recognize the picture, right? So this is actually a human trait. We can look at the picture, we can look at the video, we can look at ourselves in the mirror, and we can instantly recognize what that particular image is, right? So image recognition is one thing. The other thing which most people will probably be able to pick up is another thing that we are able to do without much thought into it is we are able to communicate in a particular language. So that ability for language is a characteristic of intelligence in humans. So we know that there are many, many thousands of languages in the world, but it all are used to communicate ideas, concepts, in some form, right? So English is what I'm speaking to you now, and you can easily recognize what I'm talking about, right? That ability for language, and not only the spoken form and the oral form, but the other form, the written form. Most languages have a written, not all languages, but most languages have a written form, and the ability for you to actually recognize the symbols being used in the written form in the text, and there's reading and writing is another characteristic that's associated with intelligent beings. So if you can create programs that can recognize pictures, can understand spoken language, that can understand reading and writing in some sort of writing, then those will be considered artificial intelligence. If you're able to process that kind of information, just like humans are able to do. Some more subtle ones would be the ability to make decisions, plan ahead of time as to what you're going to do, planning capability, and the third would be, then the fifth probably would be something which we also do every day, but you don't give it second thoughts. That every day you probably wake up from bed and then you walk from your bed to the toilet or to the washroom or to the kitchen, and you have to navigate a 3D space. There are also hazards in your house, right? You have doors, you have corridors, you have chairs, tables, armchair, etc. For a robot to actually do this, also keep balance on just two legs is very, very difficult. That ability to plan your navigation in 3D space and just control the arms and legs that you have is actually a very difficult task. So if we are able to recreate that ability to process this information in 3D space, to plan its movement, and then control the arms and legs to move in the correct direction, that would also be considered a form of artificial intelligence, because it is require human intelligence to be able to perform that. So here's a list. It's not exhaustive, and we can all associate ourselves with this because we know that we can understand images, we can understand language, we can learn new things, new concepts. We can understand the written form of some text, whether it be English or some other language. We can plan ahead. We can design robots that can actually, or we can take the place of what the robot does, right? Move around in 3D space. We can forecast or plan or predict what will happen later on today or tomorrow, and many other things. And we can do all of these things in our heads, right? In one single brain that we have. But when it comes to artificial intelligence, really, this actually would stretch the ability of AI today. Today, actually, what we have for AI systems that we are able to mimic some of these tasks, maybe not all of them, but many of them, in narrow context, right? In narrow context. So the system the AI system that can do image recognition, it will fail miserably at the task of language processing. The AI system that can do text understanding, it will fail very badly when it's used for controlling a robot. So the AI today that we have, they are very task specific or very narrow in the domain. They are able to do it only because the domain is narrow enough for the kind of processing that or the intelligent behavior that exhibit is only applicable to that narrow domain that we are applying it to. So even something that's very complex like a self-driving car, it's really not just one single AI system. It's multiple AI systems being used together. So one AI system may be keeping the car on the road. Another AI system may be just planning the route, right? From how does it get from point A to point B. And yet another AI system may be just looking out for crazy people who jump in front of the autonomous car to test the autonomous driving cars, whether it will respond correctly or not. Yeah, so it won't be just one single AI system. So the answer to this is yes, No, right? We do not have a general system that can do all of this at the same time. Although we can have individual specific AI system can do some of these tasks that we associate with an intelligent being. So this is the another takeaway. So the AI that when you want to have success with doing AI, you need to be able to identify what exactly is the domain that you want the AI to process, because you cannot build a general AI system that can do all things at the same time. So you may, depending on your problem, for your artificial intelligence of things, you may need something for the image processing part. You may also need to also have another thing that basically understands temperature fluctuations. So the two AIs will be very different. Okay, you cannot build one single system to understand both this context. But they may be related, but it's difficult to build one single AI system to actually do all things, or not possible. Okay, so just to talk about 3 or 5 big ideas of AI according to the US curriculum for AI for the schools. There are actually 2 big areas. First of all is the idea that we can replace some of the senses for human, the vision, right? We can see things, we can hear things. Being able to replace some of the human senses in terms of perception, that's one form of AI that is actually gained a lot of headway in the last few years, right? It has actually made tremendous progress. So facial recognition system will recognize the face, we can recognize pictures, we can recognize writing that's handwritten, we can also understand languages, right? So you know that things like Siri, Alexa, and Google, okay, you can basically give commands to it and it will be able to recognize your voice, right? That perception intelligence is one area that has made a lot of gain over the last few years. The other big area that has made a lot of gains is actually this whole idea of being able to learn from the data. So this is basically the area of that's called machine learning. So machine learning, being able to learn from the data to improve the performance of the system as more and more data is presented to the system, has also been tremendously improved over the last few years, partly because of the tremendous amount of computational power that we have as compared with yesteryears. Okay, so 1 and 3, there are big improvements. 5 is definitely a point that we should realize that AI is a transformative technology, very much like electricity in the 20th century, right? Because when electricity came on the scene, it does not just transform manufacturing, it actually transformed manufacturing, home life, farm, every aspects of society. And AI has a similar kind of broad impact in many, many different domains, not just at a narrow domain of just one single industry or one single context. So this is definitely one concern, how AI would impact different jobs, different aspects of society. 2 is actually the representation and reasoning capability. Now, the original AI, where people try to create an artificial brain, right, something that can think like a human, actually they focus on this part, representation and reasoning capability in the AI itself. Now, over the years, actually, this has not been as well, did not make as much advance as this fund 1 and 3. But currently, there's actually strong growth in people trying to achieve machine understanding. So in the lab stage, right, people are trying to combine some of the machine learning techniques with the representation reasoning capability of the artificial intelligence, so that not only can we predict what will happen next, but we can also reason why is it likely to, what is it related to, for example, some knowledge or some common sense about the world around that actually creates that data in the first place, right? So being able to reason, being able to infer things on top of just recognizing patterns is something that is actually very much in still an active research stage. So there are many PhDs working on this particular problem. How do we combine the learning from one set of data with the learning from another set of data so that we can reason across these 2 different sets of data? So moving beyond machine learning to machine understanding is where these folks are trying to work on. And the last area, which I mentioned last, is because actually this is my pet project, right? Because I do think that we have been stuck with a keyboard and mouse for a very long time. for the last 30, 40 years, the way that we interact with a computer is very far from what we see in Star Wars or Star Trek, where you can just interact with the robot by speaking to it, and it can understand us, and it can see what we are doing and also understand us as well. So natural interaction, this ability to just interact in a natural way as though we are interacting with another human being. I think we are not so far away from it now as we were a couple of decades ago or a couple of years ago, because today we have OK Google, we have Siri, we have Alexa, where we can actually do so to some extent interact with these systems without having the keyboard and mouse. And in the COVID situation that we are in right now, having this touchless, right, not touch-based, but touchless services, touchless interfaces may be the way forward, right? So the technology definitely makes this quite possible within the next few years. So I think we can anticipate the time when our children or maybe our grandchildren will basically not understand why we need a keyboard and a mouse, because all the future systems that they interact with will be just as though they're talking to their friends. Natural interaction. Okay, this is a big area. We already see some things like chatbots and virtual agents being deployed, but they are still very primitive to what their future generations of these technologies will look like. Okay, so this is a diagram just showing us again all these five areas in more detail. And if you really want to have more detail, just go into the source link that I provided. So again, these areas of concern for AI are really something that the US AI curriculum for schools is looking at. The AI K-12, right? It's a basic foundational understanding of AI. I think in China they have also an in China they have an equivalent curriculum as well, because both these countries are quite at the forefront of AI. They realize that there will be tremendous societal impact, so it's important to prepare the future generation for a time when, just like computers today, AI will be just pervasive. It will be everywhere. It's not just going to be one or two places, it's going to be everywhere. And with that, we come to the end. So thank you for your attention. And I'll continue with the next part, where we'll talk a little bit about more detail what is AI as well as machine learning.